React Native developers, this is our first lesson on Bezier curves, and I couldn't be more excited because this is arguably the most powerful tool in animations. And actually, this is not the first time we are encountering Bezier curves. We used it in the graph interaction, but these were functions from Redash, so things were hidden behind the scene. But for instance, a simple thing like calculating the position of the cursor along the graph in Reanimated 2 is fairly easy to do, where in Reanimated 1, this had like tremendous issues and also performance issues. So here Reanimated 2 is really great to deal with Bezier curves. You've probably already encountered Bezier curves in your favorite design tool. So here, for instance, I can draw a line and let me edit it here. So I press enter to edit the line, then I can click on bend tool. And I think you see 2 points appearing here. And so this is a cubic Bezier curves. We have a start point, destination point, and 2 control points, which we can move around. I can make this one bigger here, which we can move around to define the curve. Why this is so exciting? Well, where to start? The first thing is that thanks to this tool, so where we can express shapes in the form of cubic Bezier curves, we can see heterogeneous things in a very homogeneous things. You can have a square, you can have a circle, but you can express this square and this circle as being a concatenation of cubic Bezier curves. And if you can do that, you can easily animate from one shape to the other. And we can do it with any sorts of complex shape, as long as there is the same number of cubic Bezier curves. And we've used it also on some YouTube videos in order, for instance, to morph from one graph to another. And we're going to use it in the next lesson also to morph from one shape to the other. So a really cool tool that allows us to see heterogeneous things in a non-homogeneous ways. If you can see everything as being a concatenation of cubic Bezier curves, then things are great. You can do a lot of fun things. And then there is also a lot of interesting math we can use to implement, for instance, things like the cursor along the graph, the D3 graph that we did in the previous lesson. Another place where you might have encountered Bezier curves is for easing. So in easing, we need to go from 0 to 1. So this is 0, this is 1. And then maybe we want to start slow and go very fast at the end. Maybe we want to, go slow, fast, and then slow. These are simple Bezier curves in the sense that we're only moving the control points. The start and end we cannot change it. And so this is, as a first introduction into Bezier curve, this is the example we're going to build. So we are going to add the start and end cannot move, but we can add a pan gesture handler to control point 2 and control point 1. So this is these parameters here which are moving. And then we can use these coordinates to send an SVG command, a cubic Bezier curve command. We are into VS Code now, and this is the example that we're going to implement. So right now, nothing is moving. So we define the mean and max points, which are based on the size of the canvas, which is the width of the screen, but we removed some padding. And so you see here, so we can see it's based basically on the radius of these control points. So we have like some nice padding. So we have the start and end point, which these don't change for an easing curve. So we start at 0, finish at 1. And then we have these control points, which we display the curve here and that you see on the phone. So we have the start point, and then the cubic command from SVG, control point 1, control point 2, and destination. And then I'm going to show you another way to do it to express this path in Redash. So that's going to transition us to do more complex things using paths and redash. So yeah, we need these points. So the blue circle, the green circle and the red circle, we need to make them moving. Bear with me, it's going to be a bit boring, but what we're going to need to do is to transform these into animation values because they're going to dynamically move, which means that we need to transform all the places where these points are used, and there are quite a lot, right? For each line, for the curve, we are going to need to transform them into animated properties. So let's do this quickly. So first, we convert these into shared values. So use shared value. So let me import use shared value. Now this becomes dot value, and this becomes an animated property. So let me just add quickly. So this is, the first part is quite dull, I apologize, but this needs to be done. So we're going to create a path animated property, so use animated prop, and we're going to return the D property. So D up, and path, line, and circle from SVG become animated path, animated circle, animated line. So let me do this also quickly. So we'll have animated, so they can receive animated props. So we have path, animated circle, and animated, no, I was trying to see if you would get auto-completed, but no, animated line. Up. So again, here I'm using the Type 9 plugin for this nice auto-completion. I'm really enjoying it. So path, so here we have, so this becomes animated path, and here we can do animated props. I had a moment of pause because I'm wondering if, here I could have renamed these here and called this one path, this one circle, this one line. But I guess it's better. So then I wouldn't have to rename these, but I guess it's better to make things explicit. So line, circle. Okay, so here also we'll have to deal with this. Okay, so we did path. Now let's do line 1. So we have line 1, line 2. So these are the values we need to animate now. So I'm going to do animated props equals line 1. Again, this is going to be a little bit repetitive. Use animated props. So these are the properties we need to return. So this becomes dot value. Up. I appear to have some syntax error. Missing a parenthesis here, I guess. Perfect. Line 2, which is the same but for control point 2 here. So line 2. And now circle 1, circle 2, which are the same but with different properties. So animated props, circle 1, circle 2. So these are the same, but it's called CX and CY. So circle 1, circle 2, CX, CY. Okay. Now let's go to the control point component, because these are not number anymore, but animated shared values as well. And we can use it to display their position. So this becomes an animated view. And then we can start with the fun part finally. So let me just create a style. use animated style, transform, translate x is x.value, translate y, y.value. And we can pass it here. Oops. Okay, let's have a look. Now we're going to wrap a pan gesture handler around each control point, so we can move it around, and it should also move the curve along. So we can wrap this one into a pan gesture handler. And we're going to create a on gesture event using, you know it already, use animated gesture handler. And again, we're going to need to keep an offset. So when we start the gesture, we need to remember where we were. So I'm going to create just a type offset. XY, which I can pass as a generic. It's a second parameter. So let me import this function. For the first parameter, we use the default because we use the pan gesture handler. So that would be this one, and then offset. Okay, so on start, we set the offset. So we remember where we were. So that would be .x equals x.value, context.y equals y.value. And again, the context is here to make the gesture stateful. So we remember things across the different events in the gesture. And now on active, we set x and y. So we get translation x, translation y, the context. And so we have x.value becomes context.x plus translation x. And y.value becomes context.y plus translation y. So here, the second control point should be at the bottom. And I think here it's because I forgot to remove these props. And here's the same issue. Okay. So here now it looks the same. So let me add some color to try to debug this. So you see the square don't look aligned with the control points. And I think here is because I need to remove should I remove the radius of the control point radius? Up. So it should be perfectly centered. Yes. So now you see they look great. They're perfectly aligned. I can move them around. And I just need to add some clamping. So I can clamp the value, and let me remove this debug thing here, and let me clamp here with min max. So we never go outside the bounds. Min. Which we get as properties. Okay, so now it's working nicely, and you see I cannot go outside the bounds of the canvas. So here we're animating a single Bezier curve. We're going to use this mechanism to implement many Bezier curves, and the way we would do it in Redash. So in Redash we have a way to express path as being homogeneous concatenations of cubic Bezier curves. And here we don't need it, but I'm going to show you how to do it. It's going to be a transition to the next lesson where we're going to morph between shapes. So let me here create a path using Redash. Let me call it curves, create path, and the first argument is the start position. So x is start.x and y is start.y. And then I'm going to do add curve. So to the first argument is a path we're creating, so it's going to be curve, and then our cubic, so which has 3 parameters: control point 1, control point 2, and the destination 2. So C1x is C1x dot value, y is so C1 dot value. So behind the scene, Redash is using an internal representation that we can use to easily interpolate. So then it uses it to offer a function called interpolate path to interpolate from one path to the other that we are going to use in the next lesson, and also just to keep an homogeneous representation of different shape. You could have add line, all sorts of things, but then behind the scene, it's going to be a homogeneous representation that we can use to do lots of fun stuff, calculating the length maybe of the shape and so on. So let me import this function. So then control point 2. And destination, I guess, is end, yes. So it would be this one here. Now, so this is the internal representation from Redash. So we need, SVG of course doesn't know about it, so we need here to serialize it, and Redash also provides a function for it. So we can transform it into a string, so we can use serialize curve and serialize from Redash. And so here the example, no, it doesn't work. It's because I need to put it within the hook, right? Because of course the value doesn't change outside on the JavaScript thread. We rewrote the path on the JavaScript thread, so that's why it didn't update. And so you see how I can get confused myself, so be careful with these kinds of things. Now this is going to be executed on the UI thread. So I can return. So I'm glad that I've made this mistake. Let's have a look. So you see now it works properly. So same example, but using capabilities that are going to be very helpful in the future. So this was our basic introduction into Bezier curves. In the next lesson, we're going to implement an interesting example with it. If you're interested to learn a bit more the math behind Bezier curves, there are 2 resources which I find great. So this one, which explains really the basis of Bezier curves, so the base formula and how it works. And then there is this great resource that basically is everything you need to know about Bezier curves from the perspective of a developer. So this is super comprehensive. It has been written really in the perspective of the reader being a developer, and this is how I learned everything about Bezier curves. It's super well written. It's going to be linked below this video. I hope that you found this introduction useful, and I am looking forward to see you in the next lesson.